And now the Kumquat Institute of America invites you to spend another educational session with the idol of the nation's youngsters, our good friend,
Dr. Smith.
As we look in on the modern, well-equipped laboratory today, we find that little Jimmy Schwab is just arriving to watch
Dr. Smith.
perform his latest fascinating experiment.
Oh, Jimmy, you're just in time to watch me perform my latest fascinating experiment.
Oh, gosh, all hemlock.
Dr. Smith.
What fascinating experiment are you going to perform today?
Well, today, Jimmy, we're going to show
how our enrichments worked for our bacillus, staphylococcus, and E. coli.
Holy Ned.
Dr. Smith.
I don't know what you're talking about.
Yeah, let's look at the little isolation enrichments we did. Okay. So the first two we'll look at will be the soil. Okay. So here's the soil without any heat. And you can see that everybody and their grandmother's in there. Lots of neat stuff, actually. I know these fuzzy looking things that look all hairy, those are actually bacillus. So there's bacillus in here, I'm sure, but there's lots of other stuff too. Okay. Now, here's the heated plate. Okay, notice there's a difference in at least, amount, certainly, because when you heated things up on this plate, you killed a heck of a lot of stuff. Okay, so that makes complete sense, that result. The cool thing, though, is on this plate, by definition, since we grew these aerobically and heated the soil, pasteurized the soil, everything here should be a bacillus species. Different kinds, but they're bacillus. Whereas if you went over to this plate and looked around, you could find bacillus by fishing around, but there'd be all kinds of other stuff, lots of gram-negatives, cocci, all kinds of funny things. But you wouldn't necessarily only find bacillus. This plate, by definition, should all be bacillus. And if that's the case, look at the diversity of colony types. These funny looking ones that look like, I don't know, they're funny looking. Those little white crinkly bits, they're so cool. I don't know what they are. Then you got this big nice one here. That's a broad, simple one to get. Here's a different one. So just looking at the plate, I see 1, 2, 3, 4, 5, 6, maybe 7 different bacillus here. So that's pretty amazing. So if we took these and gram stained them, we should see a gram-positive rod, which I think I'll probably do later just to see how it looks for us. But anyway, that's a bacillus isolation. So that's kind of cool to demonstrate the importance of heat and pasteurization. Here's our pal. This was the one I streaked on the MSA plate from my nose. Okay. Notice that there's lots of different little colony types, little tiny bits and pieces. Although, and then there is some pH change because there is some yellow, but this isn't the bright yellow that you see usually when you get Staph aureus. I mean, Staph aureus, the yellow is this color yellow, and it spreads over most of the plate. I mean, you can't miss it. If you have to wonder if you've got actual aureus, it probably isn't. So my guess is I don't have any Staph aureus here, and hopefully, I'd like to try to find some and show it to you so you see what it looks like on the MSA plate. But this worked out really well. And what you would do with all these isolations, or what people have done, students did in the past, was they would go and they would pick off a colony, gram stain it, make sure it's, in this case, a gram-positive coccus. Then they'd re-streak it onto another MSA plate until it's pure, and they would turn in a pure and isolated plate, and they would turn in a gram stain, proof to me that they got what they said they got. Okay, because many times you think you have something, you spend 2-3 weeks isolating it, and you say it's a gram-negative rod, and then I look at it under this gram stain, and it's a positive coccus. So you don't want to do that. So you make sure you gram stain every time you look, so you don't waste your time. So anyway, that's Staph aureus, or staphylococci. We'll just say we don't know what kind yet, and likely not Staph aureus. And then here's the one you've been waiting for. This is McConkey's auger, and these are our pals, the lactose fermenters. Now, I wonder if it's easier to see on here. I guess it's pinker over here. Okay. What you're seeing there is each individual colony is bright pink, like bubblegum pink. Okay, so it's lactose fermenter. We know that because it's fermenting lactose. You know about fermentation, it makes acid. And so you make lactic acid, and it changes the pH and it changes it to pink. So we know these are acidic. You also notice that there's this hazy, cloudy stuff. Okay, that hazy, cloudy stuff is bile salts. So you're looking for a pink colony because of pH change. You're also looking for bile salts that precipitate because of pH change. Those two things, along with where we got this isolate, strongly suggest that these are lactose fermenters. And if we gram stain these, we'll see little gram-negative rods. And then more than likely, these are E. coli. Okay. Again, think of how many things you could have gotten out of that. And here's you only got one thing because of how we enriched for it. Okay. So that's pretty cool. So these all worked well. This plate's actually not so bad for a primary isolate. I even got isolated colonies over here. I'm just amazing. But again, this plate, you'd have to grab a colony, gram stain it, prove it to yourself, put it on a new MAC plate, and then get colonies isolated and turn it in. Okay? All fun that you'll get to miss.
Dr. Schmidt.
Has been brought to you by the Kumquat Institute of America. Today's program was the last of our current series.